Here's a jam question from 2010, and it says, moving from left to right across a period, the general rise in forced ionization energy can be attributed to the. Now, before I'm going to answer this question, I want to explain something to you. In your atomic model in chemistry, you have four kinds of shells. I've been repeating this because it is very important. You have your K shell, you have your L shell, you have your M shell, and your N shell. This shell is going to contain your first 20 elements comfortably. Now, these shells also, between these shells and your nucleus exists a kind of force. That force is called electrostatic force of attraction. Now, this force, like we established in one of my videos, that your nucleus is positively charged. Why? Your nucleus contains what we call nuclear particles, which consist of your proton, which is positively charged, and your neutron, which is negatively charged. Now, because you have two particles, one has no charge, the other has a charge, the one with the charge becomes the predominant charge of the whole nucleus. So we see that our nucleus is positively charged. Now, around this, your nucleus have what we call electron. So the electrons orbiting around this nucleus. Now, these electrons are negatively charged. And of course, if you remember your plus minus, unlike charges, they would attract. So what is happening in your atomic model is that your positively charged nucleus is always trying to attract your negatively charged electrons. And hence, while it's trying to do this, it is drawing or it is pulling these shells to itself. And as it continues to pull these shells to itself, this shell will keep on shrinking in size because they're trying to get closer to the nucleus. Hope you get that. So if you understand this, I want to explain something else to you. Now, because there's a force of attraction between this nucleus and this shell, 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 you would need some kind of energy for you to be able to remove any electron on this atomic model. Now, I also want you to know that the force of attraction between the nucleus and these shells reduces as the number of shell increases. Now, let me explain what I mean. The force of attraction between this nucleus here and this K shell is stronger than the force of attraction between this and this, this and this, and this and this. So the further the shells are from the nucleus, the lesser the force of attraction holding them. Hope you get this right. Now, I'll go again. Once this shell are far away from the nucleus, the force of attraction is going to reduce, right? Once they are closer, the force of attraction is going to increase. And that is why you need more energy to remove an electron here than you need to remove an electron from this shell than you would need to remove an electron from this shell or an electron from this shell. So having known this, what is ionization energy? Ionization energy is simply the amount of energy required to remove an electron from your atomic shell or your atomic model. I'm going to go over it again. Ionization energy is that energy or the amount of energy you have to put in to remove an electron from this shell. And like I said, the energy you have to put in to remove an electron from a K shell is not the same as the energy you're going to put to remove an electron from your M shell, your N, or your KLMN shell. Because this shell that is closer to the nucleus has a more stronger force of attraction. Now, having known that, I'm going to come back to this question. We said that moving from left to right. Now, why does ionization energy move from left to right? I'm going to explain. In your periodic table, your atoms in the same or elements in the same group have the same number of valence electron. However, down the group, your atomic shell increases. Now, remember that I said, if this shell increases, it's going to be more distant from your nucleus. And when it's more distant from your nucleus, the force of attraction is going to reduce. So if down your group, your shells keep on increasing, it means the force of attraction between the nucleus and the shells will keep on decreasing as well. Now, if this happens, what now makes across the period more stronger? Now, across the period, the number of shells you have do not increase. However, what increases is the number of electrons that you can find in that shell. And the whole concept behind this is that Once you have higher number of electrons in your shell, it gives some kind of energy to your shell, and this energy will further make it to be attracted to your nucleus. So if I have one shell here, let me explain using another atomic model. So if I have this, all right, so let's just clean the, let's see this. So if I have this is my nucleus, and I have this shell, and I have one electron here. The force I will need to remove this electron is lesser than the force I will need to remove this electron if there was another electron here. So take it as this is a marker that I'm holding, right? Okay. So the force you will need to remove this marker from my hand is different from the force you would need if somebody else comes to hold this marker with me. Another example would be the common one that your fathers use for wisdom quotes. Now, if you get a piece of broom, if you get a piece of broom, just one like this, you can easily break it, right? But when it is combined, you cannot easily break it. That's what is happening here. So when the electrons on the atomic model increases, it is going to be difficult for you to come and remove one from it. Hope you get that right. So if I have another shell here and I have just one electron, the amount of energy needed to remove the electron, it's not as much as you would need if there are 2 electrons, or 3, or 4, or 8. Hope you get this right. So as the number of electrons on an atomic shell keeps on increasing, the force of attraction between it and the atomic nucleus would increase. And as you go across your period, what increases is not the number of shell, because increase the number of shell because distance, more distance from the nucleus. But what increases here is the number of electron. An increase in the number of electron would cause an increase in the force of attraction. So this question that was asked in JAMB, that's what this question is going to be. Is it decrease in the nuclear charge? Now, what's the nuclear charge? This, right? This the charge here. So is it decrease in nuclear charge? Of course, it cannot be. Increase in nuclear charge? Of course, yes. So this charge, nuclear charge here, would increase, and it's going to draw the shell to itself, and the shell would decrease in size. So the answer is B, increase in nuclear charge. Or if you do not see increase in nuclear charge and you see increase in number of electrons, that can also be the answer. I hope you get it. And if you have any issue concerning your periodic table, I have a video on my YouTube channel that explains every single thing about periodic table. So you can get the link on my bio, click on the link, subscribe, and also watch the videos. It's going to really help you as you prepare for your JAMB 2025.